We need to get that full pull and push going through the supply chain. If we don't have the brand pulling while we push, things generally stall or end up taking a very, very, very long time. Whereas if you do have brand involvement pulling along while you're pushing the manufacturer, it seems to work better. Ultimately, everybody wants to do better and get this kind of stuff to work across not just our innovation, but others in sustainability. But the difficulty is always preserving momentum.
Welcome to this week's episode of Leaders on a Mission. I'm your host, Simon Leach, and today, we're going to be diving into the world of, I suppose, exploring and examining the fashion industry's dirtiest secrets, textile dyeing, right? It's a process responsible for up to 20% of global industrial water pollution. Which is absolutely astounding. And I suppose the question is, what if biology, not chemistry, held the key to solving this? So we're really going to dive into this topic today. My guest is, I'm so pleased, to be joined by Orr Yarkoni, CEO and founder of Colorifix. So Colorifix are a company using Symbio to reinvent how fabrics are dyed. So we're going to talk about deep tech, building mission-driven company, and the future of sustainable manufacturing. So, Orr, thanks so much for joining me on the show today.
Pleasure, Simon. Great to be here.
Yeah, thank you. And just tell me a little bit around, because I think you founded the company. Am I right in thinking it was something like 13 years ago or something along those lines? It was a while ago, that's for sure. I think it was 9 years, 3 months ago. Which is a fairly long time. You think about what's happened in the world, right?
Well, when you consider all the work before the company gets incorporated as well, then you're looking at something like 12 years now since the idea of, maybe we can do this thing, to getting to where we are today.
Yeah. But tell me though, just thinking back to, what were the main problems that you, I suppose, sorry, let me rephrase that. Why did you set this company up? What was your main kind of objective and kind of mission to create the company?
So I met my co-founder, Jim, in 2012. He hired me into his lab to work on a biosensor for water quality monitoring, particularly for heavy metals, and specifically starting with arsenic. And this is a rather large problem for South Asian countries where, we have nascent mountains that actually affect the amount of arsenic and heavy metals in the water around them. And it's a plume that moves around. So it's actually a fairly big problem. Over 100 million people a year are chronically exposed to water that isn't actually safe to drink. And it's too expensive to monitor. So we were creating a biosensor based on a microbe that would change color if the water wasn't safe to drink. And when we went and did stakeholder engagement meeting, went to Nepal, members of the team went to Bangladesh, and the like, we engaged with stakeholders at every level, from government, regional government, and people on the street, people in villages, to understand how they perceived the problem and what things they were worried about other than what we were looking at, with the idea of let's build the next sensors for the next thing, right? And they gave us a big list of chemicals that they were interested in, and we did our homework, where these things come from. And it turned out that a very large number of them actually came from textiles, and a surprising amount of those from putting color into things. Right? And then we realized, wouldn't it be great if we can get the microbes, instead of just changing their own color, change the color of the fabric, and then instead of monitor the pollution, deliver something that can solve it. And that was the idea. So we started working on that in 2013. 2 years later, we filed the patent, and a year and a bit after that, we started the company.
Amazing. Tell me, were you always an entrepreneur at heart then, do you think?
I went into academia with the idea of becoming a scientist and working on things that would make the world a better place. That was always the goal. And one of the big learnings for me personally from the arsenic biosensor project is that making something that does good doesn't work on its own. It needs to do well as do good. There needs to be a sustained activity in that area. And for something to be sustainable, it's not enough for it to be environmentally sustainable. It has to be socially sustainable, meaning that it doesn't disrupt people's livelihoods and cause chaos. And it has to be financially sustainable, because if it doesn't make money, people won't just do it because it's fun, right? That's the way we see it. So
Did you always see it, by the way, did you always see it like that? Because people talk about green premium and it's evolved, but has that always been in the ethos?
The realization came to me with the arsenic biosensor project, because this was a great product that could help a lot of people, but it wasn't going to make a lot of money, right? And that makes it really hard to put something out there that can actually make a difference, make an impact. And so with Colorifix, one of the key things we went from day zero was we need to drive this to be financially sustainable, meaning it needs to be cost competitive and ideally cost leading, right, within the sector for it to make the most amount of impact and change. So it's not something I always held in view. When we started the company, I did think, sustainability was still a luxury, as it were, in people's minds. But I mean, along the years, what has been proven is that the green premium, if it exists, is very fickle, very sector specific, and seasonal or trendy, right? Sustainability in general, people like it. And if they have the same value product, meaning quality, consistency, etc., at the same price, and one is more sustainable, they will always choose the more sustainable one. And then when people are surveyed, would you spend more on something more sustainable? Most people, well, not most people, something like 30%, I think, according to a study I read, say yes. But when you look at sales, the first time a green premium was registered, I believe, was end of 2024. There was a quarter, and it was 3%, right? But that's a one-off, and it's not enough to make a trend, because this keeps going up and down. And again, when you juggle the economic situation and how much free disposable income people have, then those luxuries of choice come down to, what do I actually need? So if we can make sustainability fulfill the need, not just the want, then we actually solve the problem.
Yeah. No, I love that. Thank you. And so tell us a little bit about, I'd love to delve into it a little bit more. What problem, tell us a little bit about the problem you're solving. I think first, let's maybe go there.
So as I mentioned, we became aware of the impact of the industry around 2012, and figures change over time, but everybody knows that this is one of the most polluting industries on the planet. The wet processing steps, specifically where you're preparing the fabric for dyeing, you're dyeing it, and then you're finishing it with softeners and all those other chemicals, that's where most of the environmental impact actually is in the supply chain, because a lot of the other parts, like growing the cotton, is regenerative. You can recycle the polyester, but the chemistry part of putting functionality and color onto the material, you can't escape that. You're using lots of water, sometimes up to 50 liters of water per kilo of fabric, right? You're basically adding lots of other chemicals in. Depending on the fiber type, it can actually exceed the weight of the fiber in chemical, how much treatment it gets from beginning to end, from the lubricants that you put on the yarn so it goes through the machine, to all the additives in the machine for the dyeing, etc., can exceed 1.2 kilos of chemicals per kilo of fabric that you end up wearing. And then you factor that you're taking all that water, all those chemicals, and then you're boiling them at high temperature for a long time. That's just a recipe for basically fairly toxic soup, right? And then what happens with that is there's about 70 to 75 chemicals that are still used today that are considered toxic or harmful. Over 30 of those are irretrievable, that are widely used in the industry, meaning no matter how you manage your waste, if you have liquid waste, it's going to go back to the ocean. And that's exactly what we set out to avoid, because you see color everywhere in nature, and rivers still run clean, right? It's not like that we see those natural dyes causing synthetic dye-like disasters out there. Even when you have incidents where natural dyes end up in the environment, they don't cause the same level of environmental impact. So we knew that nature's already solved the problem of making color. We just need to take that and put it into a context that's more useful for us in translating that to color on fabric.
Yeah, I got it. Tell me, just when you talk about, give me some more context in terms of textile dyeing. Obviously, things like jeans, I'm thinking about kind of types of clothing, like, what's dye and what's not dye. Like, for instance, your shirt, right? There's no dye on your shirt, is there, right?
So this is a Colorifix shirt. So it's
okay.
our pink. So typically, you're looking at about 100 billion articles of clothing made a year. Something like 9 trillion liters of water are used across the whole supply chain. Something close to 5.5 trillion liters of water are used just for the dyeing part, dyeing and wet processing. Then on emissions, it's one of the leading producer of emissions, not just for the wet processing part, but because of the complexity of the supply chain. You have a shirt that's made from cotton grown in India, it's woven in China, it's then dyed somewhere in Turkey before it's warehoused and sold somewhere in Europe, right? So all of those things matter because when you look at the chemistry that's used in the dye house, those chemicals each come from a different place as well. So when you look at the total carbon footprint of this industry, it is tremendous. And moving to something that can simplify that chemistry and move to green chemistry and as much as locally sourced as possible, because you can grow sugar pretty much anywhere that we have life, that's the goal for us, is to address all of those areas together.
Yeah, amazing. It's just so extensive, isn't it? Right? It really is. And okay, so tell us about, because I would imagine the issue and the challenge here are like kind of razor thin supply chains in terms of really optimized supply chains, right? Margin is clearly a huge issue here, right? So how do you, and it's complex, it's complex supply chain, right? How do you go about where do you fit in, to this supply chain?
So finding out where you fit in is really the first challenge I think a startup goes through after they've got their innovation. If it's not a B2C product where, it's just sell to the public, you need to find out where you fit in the supply chain as a B2B business. For us, the big drivers for the technology are essentially the brands because they make the supply chain decisions. So first thing you need to do is really go and engage with the end customer, meaning the last B before it gets to the end customer, and get their feedback. Make sure that they're bought in. Make sure you understand what else they would like you to have. In our case, it's always the same question: do you have black yet? Right? But ask that question a lot. Then it's about mapping out who can you actually work with, because brands don't own dye houses, right? And the mills that make the fabric don't always own the dye houses. So we have to go through the supply chain backwards to get to the right partners to work with. And then we have to onboard them, go through the technology, etc. And overall, even though that is laborious, it's more efficient than going the other way around, because we need to get that full pull and push going through the supply chain. If we don't have the brand pulling while we push, things generally stall or end up taking a very, very, very long time. Whereas if you do have brand involvement pulling along while you're pushing the manufacturer, it seems to work better. Ultimately, everybody wants to do better and get this kind of stuff to work across not just our innovation, but others in sustainability. But the difficulty is always preserving momentum with these things. As you know, in textiles, we mentioned you have the whole thing with margins. One thing that isn't touched on a lot is the turnaround on people, right? So how often people change jobs in textiles is really high. So the people you have in the brand and in the manufacturer and in the dye house, year on year, those people change. You have to keep them on board and them engaged in communicating. And I think those are the kind of challenges that we had to get on top of and make sure that our communication all the way through the supply chain from where we need to be, all the way to the end customer, meaning the brand in this case, who are making the decisions on the product, are satisfied with what we're doing and with what our involvement is. And part of that was mapping that out, understanding where are we adding value and how can we distribute, our technology most efficiently, both from a supply chain perspective as well as a revenue perspective for us.
Yeah. And we're thinking here, it's clearly a very international business. It must be, right? As you said, everything is done in different countries, right? Every step of the process.
Yeah. I mean, the global textile network is incredibly extensive. I thought that biology was complex, and then I learned how a t-shirt's made. It is quite remarkable.
Really? I thought biology was. Give me some context then. What's so complicated about making a t-shirt?
So, if we go through every element that goes into this shirt, so designer decides, I want to use this, all the work that goes behind what the designers even offered to use, right? Compiling that curation. So let's say a brand decides, I want to make a new product with a new supplier, just that one simple step, right? For a big brand, that's 2 years of audits and tests and trials before they'll place a first order, right?
Wow.
So the journey to onboard any form of new actor in the supply chain is super long, and that's per brand, okay? It's not like one brand will accept another brand's certifications. They need to certify that their supply chain is like this and have that visibility and transparency that everybody's driving for. But that does mean a big onus on the manufacturers. And for us, if we were to set a new dye house and try to onboard brands to our specific dye house, it's not going to work, because even with, let's say, H&M, great investor partner of ours, we started off manufacturing in Portugal. That's where we got our first manufacturers onboarded. And H&M really wanted to put orders through, but it doesn't make sense for them supply chain wise, because their products are made, more in Asia. The category of products that we wanted to make were not the ones they source in Europe. And for them to do anything that way, it would cost them so much more to set up logistics, the trucks to go pick stuff up, and the warehousing, because they don't have anything in the region. It doesn't make sense. The footprint of the product ends up being worse because you have to do all those tie-ins at the end. And that's just when you look at one product. If you look at a collection, right, where you're making trousers with zips that are made in one country and treated somewhere, and buttons made somewhere else, and the dye is made in one place, and the salts that go in the dye bath somewhere else, and then the yarn is a blend from 2 different places that have different amounts of metal in them, and then every product has to go through the certification of where does the material come from, where does the chemistry come from, is all of that safe for human health and the environment. So all those layers of complexity, I think, took a few years for us to get to grips with. So yeah, dyeing a t-shirt isn't as simple as take a white t-shirt and throw some dye on it.
Absolutely. And I think you mentioned to me before, it's interesting. No doubt when you think about your business model, right? And you've just outlined it there. Sometimes the tendency might be to create a color and create a dye house and then be a provider to, as parts of the value chain. But you've kind of approached this differently in terms of really being able to make the maximum impact around this. And do you know what I was thinking about as it relates to that? Because we haven't even touched upon this yet, but the biology and normally fermentation and how you grow, your product, right? And then, if that sits in some of these places, how that all integrates in. It's quite complex, right? So
yeah, there were quite a few things to tie up together.
So I know I'm warbling on a bit there. There's probably two or three things there specifically, but maybe we'll start with just looking at that, where you really find how you're going to extract maximum value and maximum impact, really, with this technology.
So we started off looking at what is the easiest, fastest way, okay? And started off with, let's get third parties to do fermentation for us. We don't want to hire a big team around fermenters, buy lots of machines. Investors generally don't like CapEx, so let's try and avoid that. On a couple of service providers, one better service, the other one not so good. I'm not going to name names, but ultimately, just the handling fees alone were higher than the price point that we wanted to sell the product. So it wasn't really a viable way for us to scale up into something that is a commodity product, right? High value products, pharmaceuticals, cosmetics, etc. Sure, you can do that stuff, but if you're trying to compete with stuff that's in the bargain bin, you can't have that pricing. So then we looked at sourcing off-the-shelf hardware and getting, customers to engage in that. That way we don't need to do tech support, they'll get their own agreements. And then customers come back to us with, A, fermenters are really expensive. We were surprised at how expensive they are. And then B, every customer came with a different fermenter model and size. And we realized if we let that happen, each customer is going to have their own set of problems, right? That is different from each other. And some of them will have problems that our team has never learned how to fix. So customer support would become basically impossible to scale if we have a model that every customer is completely bespoke process-wise. So then we decided we needed to standardize the hardware and we needed to lower the CapEx, because it really is astonishing how expensive fermenters are for what they actually deliver. They're really expensive. We bought an off-the-shelf fermenter for our site in Cambridge. That was a 30-liter machine. Cost us about £130,000. Okay.
Yeah, wow.
When we looked at
30 liters.
30 liters. Yeah.
Oh, wow.
So that's nothing scale-wise, right? When we looked at the 200 liters, I think it was almost 400,000, right? And for the scales that we're talking about here, those numbers just don't add up at all. I mean, our process is fairly efficient. We're using 5 liters, right, from the fermenter per kilo of fabric. But if you do the math there, 200 liters would be 40 kilos. And that's if you're using the whole volume. And then they're paying almost £500,000. And they need tons, not 50 kilos. So none of that added up. So we decided we're going to make our own model. We're going to distribute it. And it's going to be the same model at every customer site. We're going to make it easier to operate. We don't need fermentation scientists on site. We want machine operators to run these machines. And just simplify everything as much as possible, automate as much as possible, and monitor, right? So we've developed 2 sets of machines, a 300-liter bioreactor and a 3,000-liter bioreactor that do 50 and 500 kilo batches of the darker colors. Those can go up to over 2 tons per batch if you're doing a lighter color as well. So it depends on what you're producing. And CapEx-wise, we're looking at less for our 300-liter than we paid for that 30-liter we bought from a third party.
Right.
So the value proposition we're trying to give is not that we're cheaper, it's we provide 10 times more scale than what you pay for elsewhere.
Great. So a lot of the journey must have been creating this infrastructure, right? It's funny because you talk about but how much hard work kind of went into, tell us a little bit about that journey, because, did that take long?
Hardware is a much harder journey than we initially thought. Again, our core competencies were more around the biology end rather than the mechanical engineering end. But we built it step by step. I worked closely with Jim, my co-founder, and Rui, our CCO, in designing the machine. Rui is also head of our implementation team that introduces the customer to the technology and trains them in how to use it and provides the support. So Rui, Jim and I, in December 2020, December 2019, decided we needed to do this, that we needed to go into looking at hardware. And then in 2020, and the height of COVID, I couldn't ask anybody to travel at the time. So Rui was already based in Portugal, where the customers were. So I traveled myself, and Rui and I did the first implementation and iterations on the machine until it got to work. That was in 2020 to 21. And then we started with outsourcing manufacturing the machine whilst we set up our own assembly line. That took probably a year and a half to get set up, buy all the equipment to do CNC and understand all the certification process, because you're making a machine that works at high temperature, high pressure, and with concentrated acids and bases in different tanks. So you got to make sure everything is completely right, because ultimately issues with steam are very, very dangerous, right? And we want to make sure that this, when it gets into public hands, is the right way, and we don't run the risk of hurting anyone due to carelessness or rushing things. So the hardware thing took a bit longer than we initially envisaged because we'd had no experience with it. Our 300-liter machine is now in the version 4, which is the full commercial version that's running on multiple customer sites. Our 3,000 liters on version 2. So both of those are now integrating into die houses, which is how we're expanding things. And that brings me to the other point that you mentioned in your question as to what's the actual reason for doing this rather than building our own fermentation site and shipping the die liquor around. Well, die houses actually already have most of the infrastructure that you want to build to make a fermentation center. They have big boilers to make steam, because that's how all their machines operate. They have lots of machine operators. They have maintenance teams. They have drainage, 3-phase effluent treatment. So it basically, all the infrastructure is already in place. You just need to bring your equipment, hook it up, and train people on how to use biology instead of chemistry, really. All the rest is already there. So that realization made a very big difference for us, that we can potentially integrate the things. And we chose specifically the sizes of bioreactors that we went with to ensure it doesn't go above 10,000 volumetric bars, because that means we don't actually need to change the infrastructure in a die house. We don't need to tear up the concrete and bury the tanks or any of those disruptions that will make the die house just go like, no, I'm going to lose 3 months of business to do this, right? So all those things had to be worked out and rethought and redesigned over and over until it got to where it's working. And thankfully, that's where we are now.
Amazing. Thank you for that. Yeah, it's great to hear about a little bit about that and the journey. And so how many colors do you make then?
Well,
What can you make?
It depends on the material. For instance, for polyester and polycotton, we now have trichromatic colors. So that means we can actually mix the rainbow. We're missing black and white for those materials, but the other colors we can basically mix in now. For cotton, that's the material, let's say we have the least colors, where currently we have beige, pink, a light blue. For nylon, we have a couple of exciting colors, but still missing that rainbow spectrum. But the key one that we're working on is black, and that's the one everybody wants.
Yeah. What's the challenge with black then?
So there are 3 colors that are the most challenging to find in nature as a high-performance pigment, because we make lots and lots of colors, but not all of them perform to the extent that we need to on fabrics. So it needs to be rubbed fast, it needs to be washed fast, it needs to be light fast, because if we're making something that's less durable but greener, it's not necessarily more sustainable. It needs to be as high a quality. So finding pigments that have those performances in black or blue or green is actually really hard. So when you see blue in nature, most of the times is structural color rather than a pigment, right? So it's a group of particles of different sizes, each of them absorbing different wavelengths, and the collection of those gives you that color.
Right, okay.
So in blue, it's very structured. In black, it's very unstructured, so it's disordered, and you have lots of different sizes, and that's what makes it absorb across all the wavelengths and look black. However, there are pigments that we see in nature that can appear black and blue, and of course, chlorophyll, everything we see around us, we associate nature with green. But when a plant dies, it turns brown very quick, right? And that's because it's not very light fast. The plant is constantly making more pigment, as it were, to preserve the color. So the trick to what we're doing is to not just find these natural colors, but then screen them all for performance against each and every material. So when we develop a color, we test it against 9 different materials like wool, silk, polyester, nylon, you name it. If people are wearing it, we test it. And then we characterize, okay, this color performs on these materials. Let's take it forward and do the next round of testing with bigger pieces, and then so on and so on. We have 67 quality control points from when we start a product to when we release a product for testing with a customer, right? So that's from the DNA design point to the reproducibility and fermentation and in dyeing at the end.
Right, okay, wow. Yeah, amazing. Some process. So are you hopeful of finding a black that works in the next few years?
Well, we've had some exciting results. We've had some ones that had potential before, but unfortunately didn't give the performance, just barely not good enough. We have a new one that we're working on, but it's not ready yet, and we're not going to release anything until we're 100% sure that it's good, especially with black. Your black as a dye company is going to define you. So we want to make sure our black is definitely going to be a good enough black to make an impact in the industry.
Yeah, awesome. No, great. And so tell us a little bit about first of all, big congratulations, right? I mean, as we talked today, there was some recent kind of news out around, I think, your series, your B series or your B extension series. And as I looked through it, there's some interesting kind of companies, strategics, in the kind of space. And so maybe tell us a little bit about that. And then I'd love to dive onto the commercialization process and what that looks like for you now, I suppose.
Mm-hmm. Well, we've been very fortunate with regards to strategics believing in what we do, from both the biotech side, but more importantly, from the fashion and sustainability side. H&M was our first lead in our original Series B, and IKEA has now joined as the lead in the Series B extension. And this very much echoes our intent to go into putting color into all materials in the future, starting with fabrics, which are obviously used not just in apparel, but also in homeware and home textiles. So we're really looking forward to expanding our work there. We're
Amazing.
Testing things for paints and coatings. We're testing things for paper and packaging beyond what we already do for textiles, particularly with our print products, as once they're ready, they can be applied to a different type of printer for those other materials. And we've shown that this works quite well on plastics. We're still looking for the right partner to take that to the next stage, but our initial testing has been really promising.
Yeah,
And
really good.
it's
Really
been
good.
great
I
to have
mean,
these endorsements and their support. H&M has been great about opening their supply chain to us, introducing us to the industry and helping us learn quickly about the complexities within that ecosystem, and often helped us with that brand presence and getting the manufacturers on board, getting them convinced that there will be orders if they make a bet on doing something different.
yeah, yeah, awesome. So what does the path look like now? I suppose at this point, in terms of scale and growth now, as it were, where do you see things over the next few years in terms of the objectives of the company?
Well, right now, our key objective is to grow capacity as much as possible. That means getting more fermenters in place, making more dye liquor every day, because ultimately it's with every kilo of fabric that we dye that we're making the impact. So we just need to get that number up. And obviously, given that's the focus of the business, revenue follows as well. So our goal is simply to scale as high as we can, as quickly as we can at this point, whilst making sure we don't release things that aren't ready. So thankfully now, with regards to hardware, we got to that critical point where we have our modular scale up set up. So it's essentially a 300-liter machine feeding 3,000 machines. And then with those three, you can basically mix in any color. And we want to expand that into modules such as those to get to the capacity that even large customers are looking for. So one of the weird things in textiles is not just how distributed it is, it's the difference in size of operation and customer type. So a small dye house in Europe might dye a couple of tons, so let's say 4 to 6 tons a day. A big one will do 12 to 20 tons a day in Europe. When you go to Asia or LATAM, their dye houses do 600 tons a day. And we need to adapt this so that it works for everybody. We're starting with the ones that we believe we can make a meaningful difference to start with, meaning we don't need to get thousands of tons of capacity in place all at once, but start where it's manageable and it makes an impact to their actual production.
Yeah.
So our focus right now is still in Europe and in Brazil. We're starting in India, where we have a subsidiary now and a couple of signed customers, one of which has just gotten their GM license. So we'll be onboarding them in the next phase very soon. And in the following year, we'll go further east. But finding the right partners when you go into these regions is so important. So we're going to follow the same strategy we've done in Brazil, which is to find a large manufacturer who services this market. So this is an auxiliary chemistries manufacturer and distributor, one of the largest in South America. We partner with them towards distributing the technology. They already have the customer network. They already have the customer support team, and they're used to servicing the customer with chemicals. So why not green chemicals and give technical support to a biological process in partnership with us? So we're very happy with that model and how that's going so far. And we want to replicate that in Asia as well, because as I said, doing these things without a local partner is not just much harder, is your risk is multiplied because you don't know everything you're supposed to do in that region.
Yeah, amazing. Well, you've made some fabulous kind of progress over the few years, last few years. You really have, and you sound like you really enjoy. I remember going to your website and seeing some of the discussion with you and your co-founder. You guys look like you have some fun as well, and you seem very engaged and excited about what you're doing, right? So. Yeah, it really sounds like there is, there's great traction and kind of progress, ahead. Well, what do you think are the biggest challenges you face now? I suppose when you see what you've come through, and then you see where you are now, as it were.
I mean, the biggest challenge is still the uncertainties when you start in the new region. So dyeing is, a global activity. Even in Europe, we still do it, even though we've deindustrialized a lot of these polluting activities from the continent, still taking place daily. And in each country, each region, GM laws are different. Okay. Quite often they're around the Cartagena Protocol, and there's a shared foundational basis for how these things work. But in each country, it's a different ministry or a different department that handles it. And then sometimes within the same country, in a different region, it's a different ministry and different department, as is the case in China. So navigating the bureaucracy of starting in any one region is the biggest risk.
Yeah.
We have an expert who we have on our team, Dr. Adrian Butt, who was one of the people who wrote the original legislation for the EU, who helps us with these regulatory matters. And it really is phenomenal how different it is from country to country, and the nuances, where you're allowed to ship and import in one country and not in the other. What classification does a product come under? Is it GM or not GM? Even is it answered differently by different countries. So
I just would have thought the GM protocols would have meant, as it's not a kind of food grade product, as it were, right? GM, you talk about genetic modification, right?
So GM is for genetic modification. So the shirts are not genetically modified. So the fabric isn't being genetically modified, but the dye stuff is.
Yeah.
Right?
Yeah.
So if you're handling the process as a dye house, you are handling genetically modified organisms, within a contained use. So they need to have all the permits, registrations, everything in place before they start. Before we even ship them our strains, they need to be licensed with local government. And for each government, that is a different process, usually somewhat similar, but not very. Timelines vary immensely. Within Europe, it's usually around 45 days from you submitting an application to getting a result or a notification. In Turkey, that's 270 days.
Wow.
Right? In Bangladesh, apparently there's a route to doing it 90 days, or the standard of 270. So each region, different limitations. You have to go through that process every time with every customer, right? And I think that's going to be the biggest bottleneck really to overcome as we scale further, because when our capacity of delivering the fermenters goes up, when our capacity of delivering on media, everything else is there, our rate of being able to acquire new customers and scale them up is going to be limited on how quickly the paperwork can be put in place for those customers.
Yeah.
And that's a headache that we don't have a direct way to solve.
It's just out of your control, really, isn't it? That's the challenge.
Absolutely.
With it,
So we work with our customers, we work with local governments to ensure that everything is to their liking, because obviously we want to respect every law locally wherever we go. And that has led to some process differences. In India, for instance, every customer must have a standing biological safety committee, right, with an external member that doesn't belong to the organization, so with academia interest, etc. So navigating all of that, setting all that in place has been much more difficult than we'd originally thought, given that the product itself doesn't contain a GMO. But we got it in place, several places. We're getting in place in other ones. Some countries have changed laws in order to help us get in faster. And I hope that regulators do look at these technologies and, of ways to, given they're not at massive scale yet, give them permits to test it out and monitor them. I think that would probably make things move faster than going through that level of bureaucracy, when the amount of industrial activity you're actually doing and the risk you're posing is so small.
Yeah, absolutely. Fascinating.
Yeah.
And thank you for sharing. And we can understand. It's interesting, having worked within agriculture and food for many years, it's very party and aware of some of the challenges, the regulators, the challenges of dealing with the regulators. It really is. But, it's been a fabulous discussion. I could chat with you all day about this all, but just wanted to say thanks so much for coming on and sharing the journey. You guys are really trailblazing in this space, and very exciting to see a couple of things that I hadn't even considered, the different applications you've mentioned there. So in terms of IKEA coming on board now, and the different applications and industries you're moving into, the way you've approached the value chain here, and just the whole ethos around how you're really approaching this in a commodity marketplace. So love it. And thanks. You made it sound so easy as well, by the way. But I know it hasn't been, and I really appreciate you coming on and sharing your journey today. And we wish you all the best for the future.
Thank you so much, Simon. As you said, it's I'm glad it sounds easy. It's just a testament to how great our team is. But I assure you, everyone's had to work extremely hard to get us where we are today.
No, I know that is the case, and I'm sure, and absolutely. And to all the listeners of the show, thanks for joining. I'm sure you've really enjoyed the conversation with Orr, and we'll see you on the next show.